Imagine a world where seamless connectivity is not just a luxury, but it's a necessity for everyone in this modern world. In this rapidly evolving digital landscape, how do we prepare the next generation of wireless engineers? Hello, everyone. Welcome to our Capstone project. And the title of our project is The Deployment and Performance Analysis of an LTE Network using Blink Fixed Wireless Access Technology. My name is Tidan Visresta, and joining me Drumit Kumar Patel and Mansi Sir.
I will talk about objectives and initial setup. Our project, a collaboration between Humber College and Blink Networks, aim to provide hand-on experience in configuration and analyzing an end-to-end LTE system. We focused on setting up user equipment, E0B, EPC, while conducting comprehensive RF measurements through walk and drive tests across the campus. This project bridges the gap between theoretical knowledge and a practical application in wireless telecommunications.
So, talking about the equipment and configuration, at the heart of our project is the Blink FW300i system, which is a tri-sector and a tri-carrier LTE evolved eNode B, which operates in the band 46 and 48. We configured this versatile unit using a web UI dashboard, setting parameters like static IP addresses, carrier aggregation with 20 megahertz channel at the transmission power 23 dB. We also integrated the G-Node B CPEs for seamless connectivity.
So after configuring our devices, we performed data collection and analysis. So our drive test, we did a drive test at Blink's office at Markham and captured lots of network performance metrics and signal parameters like RSRP, RSRQ, QOI, SNR, and other different values. We processed these logs using MATLAB, applying an advanced data analysis and visualization techniques. This post-processing allowed us to extract a meaningful insights into the network's behavior, like we were able to read the throughput, uplink throughput and downlink throughput of CPE and eNode B, and which helped us to identify patterns and assess overall LTE network performance.
We did LLA and career aggregation test. For that, we conducted LLA testing using a band 46 and 48, exploring LT operation in unlicensed 5G gigahertz spectrums. We implemented a career aggregation to increase throughput by combining multiple frequency bands, and the FW300 AI supports for downlink career aggregation up to three carriers significantly enhance the data rates, allowing us to access network performance in a high density scenario.
This project provided us with invaluable hands-on experience in LTE network deployment and analysis. It effectively bridged the theoretical concepts with the practical applications, preparing us for the careers in wireless communications. Looking ahead, we aim to further optimize the network and explore advanced features like 5G integration and RF optimization techniques.
So this project not only improved LT infrastructure at Humber College and Markham office, it also equipped us with industry-relevant skills in wireless network deployment and optimization. The knowledge and experience that we gained from this project provide us valuable lessons, which we believe which will help us in pursuing a careers in telecommunication and network engineering. This project helped us to bridge the gap between our academic learning and real life application in rapidly evolving field of wireless telecommunication. So we would like to express our sincere gratitude to Mr. Paul Andrew, who has been our mentor throughout our project, and our sincere thanks to Mr. Kazi Faisal for his continuous support and direction in our project. And we also extend our appreciation to Professor Kevin Ramdas and Ms. Pooja Singh for their valuable advice. Thank you everyone for watching this our project summary. We hope you guys found it really informative. And if for any more details, you can reach any one of us. And do not forget to like and share this video. Thank you. Bye.